Okay, so for this week's demo lab, you're going to want to open up these two files. Okay, and then I also need the General Social Survey 2022 data set and codebook. So go ahead and grab those. All right, you can see I have both of those. So let's continue. So for this demo lab, we're going to do two linear regressions, one with a ratio level or ratio-like independent variable, and one with an indicator, so a dichotomous variable that only is coded as 0 and 1 for independent variable. And then for both, right, because this linear regression, our dependent variable does need to be ratio-like, and we're going to continue to use theism like we've been using in the other demo labs. Okay, so for part one, um, I chose a ratio level variable. So I chose family income K 2021. The K is for in thousands. So this is your total 2021 family income from all sources in thousands. It's 2021 because they were asked in 2022. What was your income last year? You can see the full question here. And then this one actually is they were asked in categories rather than for their exact income. And so this is actually based upon basically kind of the midpoint of each category. So if you said you made between 30 and 30,000 and 39,999, you'd be at like 35,000 kind of thing. And so it's turned into a ratio level variable of income in thousands. And then our dependent variable again is theism, which again goes from 1 through 6. 1 is atheist to 6 is theist without doubts. Okay, so the first thing we're going to do is find the minimum and maximum for our independent variable. So that's for family income. And so here I can just make sure the syntax commands are showing up in the log. And I could also go edit options, viewer, and make sure this is checked and click OK. And then for problem one, so this is going to give me the minimum and the maximum. And I'm doing the family income variable. Click and play. The other option would be to go analyze descriptive frequencies, find my independent variable. I don't need the frequency table. I don't want it for ratio level variables that are long. I mean, unless I'm trying to use it as reference or something, it's just going to be long. You can have it. You would just ignore it. But I need to click on statistics, and I want my minimum and maximum. So I'd click on check those, click continue, and click OK. And then I'm going to put my syntax and my output right here. So you can see that the minimum was $500 for family income, and the maximum was $264,610. All right, now we're going to turn on weighting and run a linear regression test. So that's right here. I only need to edit two things. The DV name, so the dependent variable, again, is theism. And the IV name is the family income one. And then I just click play. If you want to use drop-down menus, analyze, regression, linear. And I want theism in my dependent box. And then for my independent, I want family income. So you want to right click to say show names, right click to show alphabetical. Here I clicked on F, it went to the top of there. And then under statistics, I want to turn on confidence intervals and descriptives. And then I click OK. All right, so let me grab my syntax. Oh, sorry, I forgot to turn on weighting. It said turn on weighting. I didn't do that. So the weight variable name we know is weight variable. can just click that, or I can go data, weight cases, find the weight variable, put it in here, and click OK. Okay, so, and then I need to rerun this regression now that I am waiting on. Okay, so here's my syntax. And then it says that, so there's a bunch of outputs here. I'm only taking some. So I'm taking the descriptive statistics one. Let's see if I can do this or not. If I copy and paste, or whether I need to, yeah, gives me the option as a picture. Okay, model summary. So here's, remember, like the R correlations, we talked about that before, but we're skipping down. This tells me just, again, this is my independent variable. Here's my dependent variable. Here's the model summary. No. Then I need the ANOVA and the coefficient. So why don't I just take a screenshot of that whole section? Okay. Now I'm going to turn off weighting, and I'm going to do the same regression and get the descriptive statistics, because if this is weighted, this isn't the actual number of respondents, right? Because the cases are adjusted to make it better match the target population. So I want to know how many respondents there actually are. So I'm just going to go to weight off and click play, or I can go data, weight cases. I can click do not weight cases and click OK. And then this is the same as this one. So I can type out my dependent variable and my independent variable. But now that I've turned the weighting off, I'll put my syntax in there for that, I can just use the same one again. So as long as I don't have like this part highlighted, because if I do that, right, it's also going to return weighting on, but I already turned weighting off. And so I can just run this. So this is the same as that. So rather than type it out, I'm just going to click play on this one again. Again, otherwise I could go analyze regression linear, and my stuff's already set up from last time. I haven't closed out of SPSS or anything, so I don't need to do anything there. I already have my variables there. I can just click OK. And the only one we need from this is the descriptives, right? Because the rest of them, we want the one that's a little more accurate in terms of matching the target population. Okay, so now we're going to take this output and translate it into something that is a summary table that's easier to kind of see the information and understand it, and that's something more like what you would present. So we're predicting theism, and our independent variable was family income in thousands. I don't remember to have 2021. Yeah, okay, 2021. And you could even just call it that, it's okay. And so this is for significance. So let's go through here. So and this is GSS 2022. That's our data set it comes from. Okay. So for the overall, we're going to look at the model summary, and that's going to give us the R squared. And so this is 0.009, which if you multiply that by 100, you get the percent, or I can move this decimal over twice. And so R squared here is 0.9%. Okay, now we have this ANOVA test, which is the overall test, the overall F test about whether there's a significant relationship or not between our independent and dependent variable. And so overall, in our model, we can see that the R squared, we're confident R squared is more than 0, meaning that right there is some explained variance, that we can improve our prediction by knowing the independent variable over not knowing it. Our prediction of the dependent variable by knowing our independent variable rather than if we didn't know it. And so this is our p-value here. So if p is less than 0.001, that correlates with this. So I have to look at this key and find out where is it. And it's here, so I'm going to put these 3 asterisks right there. Okay. So now we have the coefficients output. So the intercept is this constant row. The coefficient value, I'm using the unstandardized coefficient B column, and so that's the 4.872. Just going to round to nearest hundredths. This again is for the significance marker, so the p-value. So I'm looking here, this is less than 0.001. And so that's again going to be 3 asterisks. If it was like 0.02, right, then that would be 1 asterisk, because it's not less than 0.01, but it is less than 0.05. If it was like 0.2, it's not even less than 0.1, so it would get nothing. It wouldn't get any markings. Okay, here I can put the confidence interval, so that's from right here. So I'm gonna, again, just round these nearest hundredths. And then the next one is the slope. So that's where you have the actual variable listed, the independent variable, and so we're using this row. And so again, I'm using the unstandardized coefficient B. This is my slope. So my slope is negative 0.002. And I'm not rounding that to 0 because then it won't have anything to show. And there's a lot of variation in income, right? So we want to see what this does or doesn't look like. And my p-value right here is, again, less than 0.001. And then I'm putting in my confidence interval. And if we see this doesn't overlap with 0, which is why, right, we have at least 1 asterisk. Same thing for here. Okay. And then since we only have one variable, this and this should generally match. Finally, I need my unweighted sample size. So that's where I'm going to the descriptives when I turned weighting off. So right here, you can see on the N column, right, 2067. Okay. So now that we have our summary table, we're going to start to explain it. So first it says, what is the value of R squared? So I'm going to go to the textbook and I'm going to go to this template. I'm going to literally use this template. So family income explains 0.9% of the variance in theism. Okay. Write your linear equation. So this is y equals a plus bx. So a is our constant or y-intercept, so that's 4.87. And b is our slope, negative 0.002. And we leave the x, which is our independent variable, and the y, which is the dependent variable there. Okay, now I'm going to graph this. Okay, so to graph it, again in chapter 12, I'm just going to download this Excel template that has both the graphing template we've already used, but then also a new one. So I'm just going to download this to use for the this demo lab. And here it is. And so first I need to put in my y-intercept and my slope. Why don't I just even be more specific? 4.872. Oh, no. Okay. And then I'm putting in my minimum and my maximum value for my independent variable. So remember we ran those earlier. Those are right here. That's 0.5 and 264.61. Okay. So now I'm going to replace my x-axis label with the label for my independent variable. So this is family income in thousands. And then I'm going to replace my y-axis label with theism. I'm going to edit the minimum and maximum bounds of this. So I want it to go from 0 to at least 264. So why don't I just have it go to 275 and it can go by 25s. Okay. And then I want to edit this. So again, theism goes from 1 to 6. So I'm going to have this go from 1 to 6 and I have it go by ones. Okay. Just move this over. Mm, there's no zero on that first one, huh? I'm just seeing if I can play with that. What happens if I do currency? Um, not just like that. And can I just put a K on the end? Let's see. No, that's great. It says in thousands. Okay. Anyway, I just wanted to add those dollar signs. I didn't need to, but thanks for humoring me for a second. So going back to what I need to do now is it says to share the graph. Let me put these a little bit more in the middle. And then I'm also going to share just the top of this, which is kind of like showing my syntax because this is what generated it. So I just want to share what I put in here. Okay. Explain your y-intercept value in real life context. So your y-intercept value is the predicted value of y. So of theism when x equals 0. So technically, we probably shouldn't make a prediction for this because it only goes down to 0.5 and dot 0, but that's pretty close. Let's just do it. Um, so here's my template from chapter 11. And again, when x equals 0, that would be 0 thousands of dollars, right? $0 in family income. And if y equals, my intercept's 4.872, that would be closer to 5, but between 4 and 5. So that would be um, believing in God, but it's between sometimes and with doubts. So let's say most of the time, but with doubts. Yeah, we'll just say most of the time instead of sometimes. How about that? Or we can say with doubts. Okay, so I would predict that respondents, right, these US adult respondents, these survey takers, who, so the ID equals 0, have no family income, would, so that's just an easier way to say $0 in family income. It's more interpretable and accessible. And then what does this mean? Would believe in God most of the time with doubt. Now I'm going to explain my slope value in real life context. Okay, so a little lower, right below the y-intercept is the slope. And here's our template for this. And our slope is negative 0.002. So on average, every $1,000, right? That's what a 1 unit increase is in a respondent's variable description. This is family income. So every 1 unit increase in X is associated with an increase or decrease of blank in Y. So we see this is negative, so it's a decrease of 0.002 units in theism. So this is again, not like the best thing. If this was something like hours worked, then we could be like, oh, it decreased this many minutes or this many hours. Because this is this weird one to where did the code book go? Oh, I can just look right here. It was the 1 to 6 scale, right? Then it's a little bit harder to understand this. So I'm going to write that, but I'm going to just also add theism is measured using a 1 to 6 scale, with 1 being atheism and 6 being theism with complete confidence, right? The no doubts. Okay, so that's fine. I'm going to use that other one though to scale it up also. So Because again, $1,000, I'm more interested in kind of people's differences broader than that. Um, and so that have kind of different levels. And so why don't we just say, let's do $30,000, right? So every $30,000 increase in family income is associated with a what? So we're going to take, before it was one unit, which was $1,000, and now it's 30 of them. And so this is 30 times as much. So I'm going to multiply that slope by 30. So it's a decrease of 0.6 units in theism. All right, and I'm just going to put that in right here. Um, and so that's telling us, right, that like it's not that big of a change, is it? Okay. Choose and share three values for your independent variable that are both substantively different from another and that make contextual sense. So what does that mean? That means that I'm going to make predictions for different income levels, and I want to make them between this minimum and maximum. I don't want it, so I'm not going to choose like $500,000, right? That's there's nobody in among the respondents with that. I mean, there could have been, but the way that this variable was set up, the top category was um, open-ended like this much plus, and so that we had to impute a midpoint, and this is kind of where how that occurred. But anyway, I'm not going to choose something unrealistic. So like, let's say this was number of hours worked. I'm not going to choose like 500. Or if this was something on a scale, let's say of 1 to 10, I wouldn't choose a 0, right? So you want it to be within the bounds of where it is. So why don't I just choose, let's see, somebody's making 20,000. So that would be, the IV would be 20. Somebody's making 60,000. And somebody's making 100,000. So now I have these that are kind of spaced apart. That's what we mean by substantively different. So I don't want to do like, oh, let's see what it is if it's 20,000, 20,001, and $20,002 in family income, right? I want to see kind of differences. So I'm kind of just here predicting like, oh, where would they be here? Where would they be here? Where would they be in between, right? Okay. So I'm going to use my regression equation. So there's a couple ways I could do this. One is I can take this actual equation and I can just plug in my independent variable and I can solve. So if somebody was making $20,000 as their family income, I would predict they'd be at a 4.83. Let's see, 20,000, 4.83. Okay, that looks reasonable. Um, the other way I can do this is I can go back to this and you'll see the last one is the predicted value calculator. So I can put in my intercept and slope here, and I can put in my slope, okay. And now I can just put in, so this is going to be 20,000, right? 60,000. You don't have to put these in to make it work. It's just a way to remember and know what you're doing here. And 100,000, right? Those were the three. And so I put in what is the value of X here? So this is 20, 60, and 100. And so, right, we can see it's giving me the answer. This looks slightly different because I added that 2. This one I didn't use the 2. But I can also just do that. So here y equals 4.752, and here y equals 4.672. Let's show my work. But again, if you prefer, you can really do, right, y equals negative plus bx. Right? Take your equation. Here, x would be 100 for 100,000. Right. So you can do it either way, it doesn't matter. Okay, and this is giving us a sense of like as you move right from like 20,000 to 60,000 to 100,000, where would you be predicted to be? Where on average in the sample would you be in terms of your theism? And we can see kind of where that is and how it changes and how much it changes. Okay. Is there a statistically significant relationship between our independent and dependent variables? How do we know? So okay, we already saw that, right? We can look here at what we already marked, which was that p-value of less than 0.001. And so it is significant. So we can say yes, p is less than 0.001, which is less than 0.05. And so what does this mean? Again, if it's less than 0.001, that's going to be over 99.9%. So 100% minus 0.1% equals 99.9%. So I'm over 99.9% confident that among US adults in 2022, there is a relationship between family income and theism. Okay. Next, is there a substantive relationship? How do I know? So we have to evaluate. So first, we have to be confident the relationship exists. So if it's not significant, right? If I'm not over 95% confident, then it's not going to be substantive. It is significant, so we are confident the relationship exists. So now, is it sizable, right? So for this, we're going to look at two things. We're going to look at the slope. So we're seeing how much does it kind of go up and change. So as you go from a lower family income to a higher family income, does it substantively decrease? So how steep is this slope? We want to think about that in context. So what does it mean to go from like a 4.8 to like a 4.5? Is that substantive? However, this is the slope of 0.002. That's a sample statistic. When we look at the 95% confidence interval for the slope, we see that if we look at the one closest to zero, we're only confident it's at least 0.001 different, right? And so actually, right, it might not even be as steep as this. It might be actually half as steep as that. So where am I would say that's not very substantive, right? We already see here that going from like 20,000 to 100,000 is only a change of less than 0.2, and it's going to be less than 0.1 when we look at that other slope. So so the sample slope is only 0.002, and we are 95% confident it is at least 0.001. I guess negative, sorry. This means that even going from someone with a family income of $20,000 to someone with a family income of $100,000, their predicted theism will not change much, right? Like it's not a consequential or big change. So I'm going to say it's not. And then when we look at the coefficient of determination, that was 0.9%. So family income explains less than 1% of the variance in theism. So there's a lot of variance, right, in theism among people. People have different views on whether they believe in God or not, but we can account for less than 1% of that using family income, right? That's only explaining some of that variation, and it's less than 1% of it. So overall, I would say, right, no, it is not substantive. Okay, so while it was significant, right? So we're confident there is a relationship, right? We're not confident that the size of that relationship is meaningful or big. Okay. Is there a causal relationship? So I'm going to say no because it wasn't substantive. So significance, yes. Substantive, no. Causal order. So this is saying, is it more likely that income would explain your theism or theism would explain your income? So I don't think being more atheist or more believing in God is going to change your income. I mean, obviously, if you have a certain profession, it might, but outside of that, no. So I think it makes more sense that family income might affect things like education, social networks, um, geography, politics, etc., all of which could impact theism. However, theism is not going to influence how much your family makes. Therefore, the causal order is correct, right? So we're basically saying, did we identify our independent variable and dependent variable correctly? Because they could be switched, right? You could test for something. Let's say we looked at age and political party, and we said, and we had political party as our independent variable, and we had a substantive relationship, right? But we don't want to say that political party changes your age, right? That it has an effect on variation of the age. So we'd say, oh, the causal order is wrong. Actually, there's not a causal relationship where political party is affecting age. The causal relationship is age affecting political party. Okay, theory. So here again, there wasn't much difference, but as people got wealthier, or sorry, as their income grew, their family income grew, they were slightly less theistic. So why might that be? I don't know. I'm just gonna come up with something. So people with higher family incomes may be less dependent on God because they have more personal agency, and so don't attribute as much to higher power. Okay, so I want to again explain what might be going on in terms of why might we have found that people with higher incomes had slightly lower theisms on theistic beliefs on average. And then non-spuriousness. So this thing is there something that might come before family income that would explain away the relationship between family income and theism? Parents' family income? I don't know. I'm going to say that I cannot think of a preceding variable that would explain away the relationship. So again, you're often it's going to be non-spurious. It's going to be spurious more often if your independent variable isn't something like family income or age or race or gender or something, but it's something like a certain political belief or something else that has more things that might come before it that could explain it away. So we can see that all of these could work except for the substantiveness. And so, it could be causal where it's having an impact, but it's having such a slight impact, but it's not having enough that we care about it. And so it does not meet all criteria as it is not substantive. The relationship does not meet all criteria as it is not substantive. So no, there's not a causal relationship. Okay. That's part one. Part two, we're repeating. We're just going to do a different variable and we're going to, things will be slightly different for it. Okay, so for this, we're using the same dependent variable, but now we're using an indicator variable. So that's one that's labeled 0 and 1, a dichotomous variable with only 0 and 1. We can use indicator variables for independent variable in linear regression. We can't for our dependent variable. If you did that for your dependent variable, you'd switch to something else, which is logistic regression. And binary logistic regression is not something that we're doing right now. We're doing linear regression. So we need a ratio-like or ratio-level dependent variable. So here's grass. So the question is, do you think the use of marijuana should be made legal? 1 is yes, 0 is no. So we know the coding. We know there's people in at least both categories. We don't need to run the minimum and maximum, right? It wouldn't be a variable. It'd be a constant if everybody was in 0 or 1. And so we already know the minimum and maximum in the two options. So we're just going to run our regressions. Okay. So I could go to part 2 and run these, but it's actually the same as part 1. So actually what I'm going to do is I have, again, I could type in this stuff, but I'm just going to switch. I still have these. I'm just going to switch family income out for us. Okay, so I want to turn weighting on. Remember, I turned it off to get the descriptives. I want to run my regression. I want to turn weighting off. Then I want to run this regression again. Oh, that was 2 questions, but that's okay. And again, I could also go data weight cases. Weight cases by and click OK to turn it on. Later, do not weight cases and click OK to turn it off. I can go analyze regression linear. I already have the things set up that I need. I already have theism here. The only thing I need to do is take this out and put in grass instead and click OK each time I do that. Okay, so going back to here, so we have my syntax for this one, and then I turned weighting off. I use the same regression. And then let's put in the outputs I need. So for the second one, I just need descriptives. Right, to grab that sample size. For this first one, I'm going to need descriptives again. We don't use this, but it's good just to see how it's different. And that way, we know that it's also weighted or not weighted, that they're different there. Just screenshot it. And you can see here how the correlation coefficient, R Pearson's correlation coefficient is negative 0.282. And you can see here it's positive because, again, this is the absolute value. And so we don't ever want to think about direction from the model summary R. We always want to get that from here. This is bivariate only, whereas later we'll get into multivariate, which is why this provides an absolute value. Anyway, let's capture these. Okay, so we're going to fill out our table. So again, this is predicting theism. Our independent variable here is grass. And then our data set is still GSS 2022. And we're going to fill out everything the same except for this thing. So this looks a little different here. Before we had intercept and slope, but we didn't put labels on them of what they mean. You can see it just says intercept and slope. But now, right, it's just 0 or 1. And so this is going to be don't make legal. Let's see, how do we want to word this? I mean, if I call this marijuana legalization, I could just say no and yes, but this should be, let's just say illegal, right? And legal. So this is somebody who says it should be legal, should not be legal. Somebody says it should be legal. Okay. So we'll put in the rest of the stuff. So why don't I put this out here on the same side? So again, our unweighted descriptives, 1107. That's my unweighted sample size. That's how many respondents I have that I know information data on for both of these. And then let's go back to the weighted one. Okay, here's my model summary. So R squared 0.079. I'm going to move that decimal to the right, or I can multiply it by 100. And so I get 7.9%. Okay, here's the ANOVA. So this is the overall model's p-value. And so you can see it's less than 0.001. So that's going to be 3 asterisks again, right? And if that was like 0.049, I would put 1 asterisk. If it was 0.2, I would put none of them. If it was 0.09, I'd put a tilde. Okay, and then in the coefficients, again, this is the intercept line, this is the slope line. I'm using these b's. They're both p less than 0.001, so that's 3 asterisks. And my confidence intervals. I would probably round all of this the nearest hundredth. If I was presenting this in a journal article or something else, I don't think you need this level of specificity. I'm just leaving it here because I like how I can use those for when I do my graphing and make predictions and stuff. So, when you start multiplying or doing other stuff, these can have a little bit more impact. And I just want to have more accurate results. So I'm just leaving them in so I can pull them from there. But I normally, if I was presenting this, I would not leave it out that far. And in fact, right, you can see that we actually have the option. There we go. Well, when I double click, it should give me a more specific numbers, so it would even go out further. You can see instead I got this rainbow of death that's not going away. And so I could wait and see if it eventually loads. But more likely, if I get that, I'm going to have to just quit SPSS. I'm gonna have to force quit it, and then I'd have to rerun the stuff so if I didn't capture anything and I get this, that's why it's really good to have that syntax so I could just click play rather than having to do everything again. So anyway, and I was just saying that it actually would go out further. It could be 4907 or 491034 or whatever. Like it keeps going. Okay, let's get back to here because we have everything we need for it. So what is the value of r squared? Explain what it means in context. So again, remember, we're using that same template. X explains, oops, r squared of the variance in y. Sort of the same thing, except in this case, it's views on whether marijuana should be legalized explains 7.9% of the variance in theism. Paralinear equation, y equals a plus bx. So we know a is 5.491. B is negative 1.008. And now we're going to graph it. So it says using the worksheet bivariate graph dot indicator IV. So because we only have 0 or 1, we're not going to have a line, right? You'll see this sometimes in articles. I don't think it's good when they do this, when it's categorical, but there's only going to be 2 values, right? The 0 and the 1. And so it doesn't make sense to show this kind of line like that. And so instead, we'll just do a bar graph. So I'm going over on the bottom to where it says bivariate graph dot indicator IV because I have an indicator independent variable. So I'm going to put in my intercept. I'm going to put in my slope. And now I have this. I need to change these. This is theism. This is views on legalizing marijuana. Oh, and then I also need to replace these yellow ones. So it says IV equals 0 label. So that's right. It should be illegal. But equals 0. So just we know that that's came from. Should be legal equals 1. Okay. Or if I have this as views on legalizing marijuana instead of grass, I could even just say no and yes. And then I don't need to change my x-axis because it's either 0 or 1. That's all. But I need to change this to back to the 1 to 6. Okay. So I want this to be a little more centered. These are a little small. Okay, so here's my graph. And then I also want to include the top part to show my work. I'm going to move this graph over because I just want to be able to see this whole text and I don't want to affect the graph. Okay. Okay, what is the value of the y-intercept? So it's 5.491. What does this mean in real life context? So again, it's when x equals 0, we would predict that y equals 5.491. We have a template we can use for that. Let's see if it's any different than what I just wrote. Yeah, like that. It's a little more eloquent. So I would predict that respondents who are to 0, so what does x equals 0 mean? Who oppose legalizing marijuana, who said we should not legalize marijuana, oops, would be at a 5.49. So like halfway between 5 and 6. So if we go back to theism, you can see a 5 is believe with doubts and a 6 is believe without doubts. So would be halfway between believing in God with doubts and believing God without doubts. So let's just say they like would believe in God with only minor doubts. Okay. And then what would we predict when x equals 1? So again, I can use my predicted value calculator if I wanted to. So if I go back to that spreadsheet, I could go to the predicted value calculator. And I could put in, right, 5.491 and my slope of negative 1.008. And I'm making a prediction for 0, which is right, do not make legal, and 1, which is do make legal. And we can see, right, that we have this for 0, and then for 1, it's 4.483. We can see that's actually the same number here. So this made the prediction. Or I can just do this, which, I mean, if I click on here, you can see it's actually doing this formula of y equals a plus b times x. So if I grab my equation, right, you can see actually this one, we're predicting it for 0. And so it ends up being 5.491. And for this one, it's predicting it for if x equals 1, right? If somebody believes that marijuana should be legal. And so that ends up being this, or right, 5.491 minus 1.008, which is 4.483. Okay. And now in real life context, what is a 4.483? It's about 4.5, so it's about halfway between 4 and 5. And so this is, I would predict that if x equals 1, so someone who supports legalizing marijuana would be between a 4 and a 5. So between sometimes and with doubts. So why don't we say would believe in God most of the time. Okay. Or we could say often, but with minor doubts, something like that. Explain my slope value in real life context. So my slope again was negative 1.008. So that's the difference between here and here. So it's the same thing as before, right? As x increases by 1 unit, my dependent variable decreases by 1.008, right? Or it goes up by negative 1.008. And so the theism views go down by about 1, right? Or if this was something else, like income is our dependent variable and it was like 30, then we could say, oh, it's going up by 30,000 or something, right? But that's for each unit increase in X. So last time, remember how income could go up a lot? That was our independent variable. Or if you had something like TV hours as your income, as your independent variable, right? You could have that go up repeatedly. For this, we only have 0 or 1. So it doesn't make sense for us to say as X increases by 1, this is what happens. Instead, we're just going to make a comparison. So as we go from here to here, we're going down by 1. So basically saying this is 1.008 lower than this. Okay? If this was like 5, I'd say this group is 5 units for the dependent variable higher than this group. Okay, so I'm just making the comparison. So um, oops, I went way too far down. Okay, I was having trouble finding it because I was in chapter 11. So chapter 12, interpreting slope with an indicator IV. So here's our template. This is an example, right? So IV equals one category name. So that's the respondents who support legalizing marijuana. Their average theistic views is predicted to be negative 1.08 higher than IV equals 0 category name. So that's respondents who oppose legalizing marijuana's average theistic beliefs. And then it says, if the slope is negative, share the absolute value for the slope value and change higher to lower. So we're not going to say that it's negative 1.008 higher. We're going to say it's 1.08, right, units lower. And again, if the units was something interpretable, I mean, like, well, in the feeling standard, we'd say degrees. If it was income in thousands, we'd say, right, $30,000. If it was, right, height, we'd say however many inches, right? So we'd make it make sense. For this one, we don't know exactly what this means from here. And so we're just gonna add the context of what it actually is by saying that same thing I said earlier, which was, here we go, how theism is measured. So you can just kind of get a sense of it, of what a 1 means. I mean, I could say like what percent of the scale it is or anything else, but I'll just leave it at that. Okay. So is there a statistically significant relationship? How do I know? So if I look at my table, right, remember it was 3 asterisk, P was less than 0.001. And so it was. That was our same answer up here. So why don't I use this and change some things? So yes, I'm over 99.9% confident that among my target population, there's a relationship between views on marijuana legalization and theism. Is it substantive? So we know, yes, it is significant. So we're confident the relationship exists, but is it sizable? Let's see. So we want to look at the slope and r squared. Well, r squared was 7.9%. Yeah. Um, So that might seem small to you, but I'd say any R squared 5% or higher is generally substantive. This is saying that if it's 5%, that means that we can explain 1/20th of the variance based upon this one thing. So, right, there's a lot of things that would go into why people have different theism, like theistic beliefs about God. And so we're not going to find one thing that's going to explain all of it, right? And so to say, oh, we can explain, um, will 10% be like 1/10 of that variance, or 5% be 1/20th? So let's say like 1/15th or so, right? We can explain a good portion, right? Like there's still most of it's not of the variance is not explained, but we can explain a good portion of it, um, of that variance based upon knowing people's views on marijuana legalization. This is a sample statistic, but and then the slope was 1.008, right? Well, negative, but I'm interested in the absolute value. So the sample slope is over one category different in the theism variable, which only has six categories. And so that to me, the sample slope is substantive, but let's look at the confidence interval. So we're confident that it's at least 0.82 different. And so if I think about that, I'd say that's still, on this 1 to 6 scale, um, pretty substantive change. So it's not necessarily going all the way there, but right, if you think about this gap as being like zero point 0.8, from wherever to wherever, um, on a scale of 1 to 6, where right the whole thing goes 1, 2, 3, 4, 5. If we were to do 0.82 divided by 5, that's 16.4%, right? So we're confident that among the whole thing, right, that it's at least 16.4% different in terms of like the amount of this. Not these two, but I'm saying in terms of like among this scale, right? So I would say that where were we? Here. Um, I'd say that's a meaningful difference considering we have a 1 to 6 scale. So we're at least 3/4 of kind of a unit different out of just the 1 to 6 qualitative different ordinal areas. So I'm going to say yes, it is substantive. Okay, because we said the relationship exists. We said that there's enough explained variance, and the slope, including considering its confidence interval, is also big enough. So is there a causal relationship? So we said it is significant. We said it is substantive. Causal order. So would your belief in God affect your views on marijuana legalization, or do your views on marijuana legalization affect your beliefs in God? I mean, it depends on what those beliefs are. I would say probably people who are more certain probably have more traditional beliefs in God. And so Does it say God or it says like, yeah, it doesn't say higher power, right? It says it's using the term God. And so I would say that people who say I know God really exists are probably more likely to be members of more traditional religions, which probably are less into marijuana legalization. Um, Obviously, somebody could believe in a God that says, go use marijuana, make it legal. But I would say that probably their theism is more influencing this particular political belief. So I think the causal order is wrong. It's reversed. Theism might impact how you feel about marijuana legalization, um, because your theism might make you part of certain social groups that have shared political ideas, philosophies, positions. Um, could marijuana legalization impact your view on God, like your views on marijuana legalization? Um, it could. I think that actually goes to the non-spuriousness. Um, I'd say it could be spurious. If we took the actual causal order as right, um, it could be political views, which explains away the relationship. So people who are more, let's say, liberal, um, are more likely to both support marijuana legalization and be less theistic. Whereas people who are more conservative are likely to be less supportive of marijuana legalization and more theistic. And so it could be that political views comes before both of these, and it's explaining it away. Um, and theory, we did have a theory. The theory showed how the causal order was maybe backwards. So um, that was where people who are more theistic are more likely to be part of more traditional religious institutions, which are more likely to. So this is kind of explaining how it's mediated, the mechanism how you get from the independent variable to the dependent variable, which are more likely to oppose marijuana legalization. And those who are less theistic are probably more likely to be part of organizations, or not organizations, but organizations or even religious institutions that are more um, are less strict about things like marijuana and or have more socially liberal views, or take more liberal political positions, and don't want to criminalize people's participation in things like marijuana. Uh, okay, so that is the demo lab.